Okay, this is just a continuation of AP Calc BC Chapter 9, the third packet of particle motion. So this is starting on page 4, so page 4. So we're taking a look at that acceleration, velocity, position type of relationship, but in particular we're looking at it with the graph again, so velocity graph. So just a reminder, acceleration is the slope of velocity graph, right? So we look at the slope. Displacement is calculating the area bounded by the velocity graph and the x-axis. And so with displacement, we would be looking at like positive above, negative below. But the distance traveled would be the absolute value. So even though this would be above, we would look at this as a positive value here. And then average speed, so this is a little different here graphically. So we're looking at the total distance traveled divided by the total time. Whereas average velocity, so remember speed and velocity, one is positive, right? So that's always speed. And velocity could be positive or negative, so it has direction. Oops, sorry. And average velocity is the net displacement, so that would be positive and negative taken into account, divided by the total time. So for question number 1, it's asking for during which time interval did the particle travel in a positive direction. So that positive direction is when velocity would be greater than 0, right? So when the velocity would be greater than 0. And that would be when it is above the x-axis. So it is above the x-axis on this section right here. And so that would be starting at t equals 0 and ending at t equals 30. So that would be from t equals 0 to t equals 30, and they gave us units, so we'll add those in there. So from t equals 0 to t equals 30 minutes. So then for question number 2, when did the particle travel in a negative direction? So that would be when velocity is negative or less than 0. Sorry, my lights keep kicking off. And so it will be traveling in a negative direction when velocity is actually negative, and so that would be below the x-axis, so that would be from here at 30 and ending here at 55. So that would be from t equals 0 to t equals 55 minutes. Okay. All right, and then for question number 3, so how far did the cart travel in the first 10 minutes? So how far it traveled in the first 10 minutes, so we would look at position, and so if I have velocity and I want to go to position, then I need to integrate. So I'm integrating from 0 to 10, and then v of t dt, and we're looking for distance, so that would be absolute value. And so then we are just looking for the area from 0 to 10, right? So I'm looking for the area from 0 to 10. So that would be the area of that triangle there. So then a triangle would be 1/2 the base, so from 0 to 10, so that'd be 10. And then times the height, so from 0 to 60, so 60. And so that would be 300 meters, so 300 m. Okay, so distance traveled. And then for question number 4, it's asking for the average acceleration between 10 and 15 minutes. So average acceleration is the change in velocity, right? So change in velocity over the change in time. So how far did the velocity change from 10 to 15? So from 10 to 15, so that would be this section right here. So right there. So the velocity at 10 minutes was 60. It was also 60 at 15 minutes, and then over the change in time, so 15 minus 10. So it went from 60 to 60, so it didn't change at all, and then 15 minus 10. So that would be 0 over 5, or in this particular problem, that would be 0. And then this was meters per minute here, right? And that was minutes down below. So the velocity was given as meters per minute, and then time was minute. So we have meters per minute divided by minute, so that would be meters per minute, and then squared. So meters per minute squared. Okay. All right, and then for question number 5, they're asking for how far did it travel in total. So they're looking for total distance traveled. So total distance traveled from 0 to, what is that, 55? And then the absolute value of v of t. Oops, so b of t, there we go. And then dt, so absolute value. So we need to find the area of each of those pieces, and because it's asking for how far and total distance, so we have to take into account that even though this is below the x-axis, we're going to treat it as a positive value. If it had asked for its position, then I would keep it as a negative, right? So we want to look at that as a positive. So I already found that first section, so that first section was 300. And so then now I'm going to go ahead and just kind of break it up into pieces here. So then I have this next section here, which is just this rectangle. And I want to find the area of that rectangle. So this is a block of 5. So 5 times the height, which was 60. And then if I take a look at the triangle now, so that would be 1/2, and then that base, so that base is going from 15 to 30 with a height of 60. And then this triangle here, so this last triangle, would be 1/2, and then that base is going from 30 to 55. And then that height, even though it's negative, because we're doing distance, it will keep it positive, so that would be 40. So let me do a little arithmetic here. If this was the AP test, you wouldn't need to do the arithmetic. You could just leave it. What is that, 500, I think? So 1050, so 1550. Hopefully that arithmetic is right. So that would be for a total distance traveled of 1,550 meters. So the original area had the next rectangle, and then I had 2 triangles after that, and then that would give me that total area. All right, and then for question number 6, so what is the average speed? So this is from above, right? So average speed is the total distance traveled, which we just got done calculating, divided by the total time. So our average speed is the total distance divided by the total time, right? So from question number 5, we knew the total distance was 1,550 meters, right? And then that total time, because we went from 0 to 55, would be 55 minutes, or the change in time. And so whatever that particular value is, that would be our average speed. And again, we can leave it like that. We don't need to have a number value unless it was like multiple choice. Okay. All right, and then let's take a look at question number 6. Okay. Get a little organized here. All right, so this is on page 5, question number 6. So for this one right here, so we are looking at a velocity graph again, and just asking us questions just like we did on the last one, just making sure we kind of know that. So we're given this graph of velocity, and there aren't any units on this one, which is fine. And then we know we have a semicircle, so a semicircle here, and then 2 line segments, so we know these are straight lines, and then just different questions. So for part A, they're asking for on what interval from t equals 0 to 11 is the speed of the particle increasing. So in order for the speed of the particle to be increasing, then that means your velocity and acceleration have to have the same sign, right? So for speed to be increasing, then velocity and acceleration have to have the same sign. So that means we're looking for where if velocity is positive, meaning it's above the x-axis, and then we also want the slope of velocity to be greater than 0 as well. So we want, since acceleration is a derivative of velocity, then we want slope to be positive and also velocity to be positive, right? So that's one situation. So let's find that first. So velocity meaning greater than 0, so that means above the x-axis. So that would be this little section and this little section, but the slope has to be positive as well. So if I look here from 0 to 2, velocity is above the x-axis with a positive slope. So that means one of the intervals, so speed is increasing. On the interval from 0 to 2. And then over here, speed would be decreasing because even though velocity is positive, the slope of that section of the graph is negative. So this would be where speed would be decreasing. And then over here, so from 10 to 11, so from 10 to 11, I know velocity is above the x-axis and it has a positive slope. So there's another section where speed is increasing. But I also have to take a look at that other situation. So that was one situation, right? And then a second one. So let me just kind of write that over here on this section. So if they have the same sign but both negative, so maybe velocity would be negative and then the slope would also be negative, right? So that would be another time where speed is increasing. So velocity would be negative when it's below the x-axis, so that would be this little chunk right here. And then on this little section, I'm looking for where the slope has to be negative as well. And so that would be where speed is increasing. So I have a negative slope here as well. So that would be from 4 to 8. So our last section would be from t equals 4 to 8. So this section right here, we have a negative velocity, but it has a positive slope, right? So that would be where speed would be decreasing. Okay. All right, and then for part B, we're looking for where the acceleration of the particle is negative. So acceleration of the particle negative would be when velocity is decreasing, right? So that would be, since the derivative of velocity is acceleration, then we're looking at slope of velocity, right? So that would be where the slope of velocity is negative, right? That's specifically what we're looking for. So the slope of velocity would be negative, so that would be this whole section right here, right? But I want to split it because right here it's not defined, right? So I don't want to go from, like, say t equals 2 all the way out to t equals 8, because right here it's not negative, the slope is undefined here. So I would say that acceleration is negative. On the interval from 2 to 4, and then also from 4 to 8. So I don't want to include that value of 4 because it's undefined there. And then it says to explain it, and so I would just say because v of t is decreasing, or maybe you would say because the slope of velocity is negative or something along that line, right? So that would work as well. Different ways to answer that same question. All right, and then for C, we want to know over what time interval is a particle moving left. So I know that the particle is moving left when velocity is negative, right? So velocity is negative when it's below the x-axis, so that means that would be this little section right here where it's below the x-axis. So that would be from, so let me make a sentence here. So the particle is moving left from t equals 4 to, so it stays below until we get to here, so that would be to t equals 10. And then that is because velocity is negative or less than 0, different ways to say that. And I'm just going to go because v of t is less than 0. So that says the same thing, right? Velocity is negative. Velocity is below the x-axis, different ways to say the same thing there. Okay. So now then D is just kind of the reverse of A, right? So we're looking for where speed is decreasing. So we're looking for where velocity and acceleration have opposite signs, right? And so acceleration, remember, is a derivative of velocity. So in particular, we're looking for where like acceleration might have, let me say that again. So in particular, we're looking for where like the slope of velocity is positive, but velocity itself is negative, or where the slope of velocity, so that they're opposite. That's what I'm looking for. Okay, so when I look at my graph right here, so let's start with where maybe velocity is positive, so that would be on the sections where it's above, so like the semicircle piece and that piece here. So velocity is positive here, but I'm looking for where it has a negative slope, right? Because I want the sign to be opposite. So velocity is positive here. Where does it have a negative slope? That would be from 2 to 4. So from 2 to 4, velocity is positive, but acceleration is negative because it's decreasing. And so that would be where speed is decreasing. So speed would be decreasing. Oops, that's not 0. How about from t equals 2? Sorry about that. Yeah, there we go. So from t equals 2 to t equals 4. And so that's specifically because although v of t is greater than 0, meaning above the x-axis, the acceleration is negative, and that is because our slope is negative, right? So the slope of velocity is negative. Okay, so then let's take a look at the reverse. Okay, so we looked at where it was above, and so now let's look where velocity is below. So velocity is below here, so this is where velocity is negative, and so acceleration would be positive on the section where the slope is positive. So right here, the slope is negative, so that would be where speed is increasing, but here, your slope is positive and below the x-axis, so that's another section where speed would be decreasing. So that would be from t equals 8 to t equals 10, and then that's the reverse, right? So because velocity is below the x-axis and yet it has a positive slope, so acceleration would be positive. Okay. All right, so for part E, we want to find the total distance traveled from 0 to 11. So total distance traveled, so that is the absolute value, right? So we're looking for the integral from 0, how about 0 to 11? Sorry, 0 to 11 of the absolute value of v of t dt. So we're going to have to find each of those areas, so from 0 to 11. So I'm going to do some back and forth here. So that first section is a semicircle, so the area of a semicircle is 1/2 pi r squared. So I would have 1/2 pi, and then the diameter is 4, so the radius would be 2, so 1/2 pi r squared. And then the next section, so I'm going to be jumping back and forth, is area of a triangle. So this area of a triangle. And I want distance, so that means I'm going to, even though it's below, I'm going to treat it as a positive value. So I want to find the area of that triangle. So that would be 1/2 the base. And then that base is going from 4 to 10. So that would be a base of 6. And then the height is down to 6, but I'm going to treat it as a positive value. So 1/2 base, which is 6, times height, which is 6. And then finally this last little sliver right here, so I need to do that one as well. So I want to find the area of that triangle. So the area of that triangle is 1/2 base times height, the base being 1 and a height of 3. And again, I'm treating all of those as positive values because I'm working with distance. So then if I simplify that just a tiny bit, so 1/2 of 4 is 2. That would be 3 times 6 is 18, and 3/2. And I could keep going, but I don't even need to do this line, right? If I just need that, I could just stop right here, and that would give me a value that I want. Okay, and then for F, they're wanting something similar, right? So asking for the value of the non-absolute value version. So E was for the absolute value, and then F is not the absolute value. So that means if it's below, we're going to rewrite it as a negative. So the areas are still going to be the same, right? But the semicircle was above, so it's going to stay positive. But this triangle was below, right? This one was below the x-axis, so this one's going to convert to a negative. This one was above, so it's going to stay positive. And so they asked you to explain the meaning of that integral. So this is, so that integral then is the change in position, because we're taking into account, like when it's below the x-axis, it's moving like leftwards, right? And we want to make sure we always reference the limits here. So from t equals 0 to t equals 11. And they didn't really give us units, so we could say minutes, but if they don't give us units, we don't have to like have something specific there, okay? All right, and then last one here, so initial position is 2, so it started out at 2, and they want the position of the particle at 11. So that would be, this was our change in position right here, right? So our change in position, and we started here at 2, so then the position would equal our initial, which is 2, plus our change, which is what we found in part F. And that would be it. And again, we could combine like terms, work that out, but that would be good enough. Okay? All right, and that's going to be the end of this video.